Hello, this is the first episode of a series of videos called My Publication at a Glance. The idea is to highlight young medicinal chemists with very recent publications. Today, I'm very glad to welcome Aline Delamare, who is PhD student at the Institut Européen de Chimie et Biologie of Pessac. Thank you, Aline, to be the first.
Thank you, Nicolas, for giving me the opportunity to present a part of my PhD work. So today I will present our latest methodology enabling the introduction of hexafluoroisobutyl group via a tandem process. The isobutyl side chain notably constitutes the side chain of leucine, which is present in many therapeutic peptides, but also a myriad of other drugs, such as butalbital and tetrabenazine. Changing from the isobutyl to the hexafluorinated analog increases the volume about 48%, the dipolar moment, and the hydrophobic character while maintaining the global morphology of the hydrogenated side chain. In literature, several synthetic pathways have already been published to build the hexafluoroisobutyl chain of hexafluorosin, but they have limitations: numerous steps, expensive reagent and gas, and these syntheses were only applied for one substrate. In this context, we challenge ourselves to develop a direct and global methodology to build the hexafluoroisobutyl group in one step. Our main purposes were also to avoid gas as fluorine reagents and to overcome the usual SN2' mechanism for trifluovinyl groups for those the CF3 moiety is not retained. We thought about using this brominated reagent, which is an affordable liquid. We investigated the reaction with this substrate, ethyl-2-methylacetoacetate, in order to obtain the hexafluorinated analog. First, we test alkali bases, and surprisingly, we obtain as a major product this pentafluorinated compound and only a few amounts of this hexafluorinated molecule. At this point, we ask ourselves if these pentafluorinated compounds could be enough electrophilic to be fluorinated in the presence of a source of fluorine. We thought about using TBAF. Unfortunately, with 4 equivalents, we obtain as the major product this pentafluorinated compound again. But after optimization, we found that using a large excess of TBAF, 10 equivalents, allows to obtain selectively this hexafluorinated and desired compound with a nice yield. With this optimized condition, we investigated the scope of the reaction with various functions and substrates. We have 1,3-decarbonyls, shift bases, and malodonitrides. Afterwards, we applied this methodology for the synthesis of enantiopure hexafluorosin, a fluorinated amino acid of interest. To do so, we used the stereoselective homologation of this chiral nickel complex, initially developed by Belokon and later used by other research groups such as Solutionov, Koch, and Lionov for the synthesis of fluorinated amino acid. With the previously optimized condition, we succeed in obtaining a 66% yield and a nice diastereoselective ratio. This methodology is compatible with a multigram scale synthesis. We obtain the pure diastereoisomer of the alkylated nickel complex, and after hydrolysis, the enantiopure hexafluorosin, and it's quantitative. We then performed a mechanistic study thanks to fluorine and photon NMR, and based on our observation, we proposed the following mechanism. Under basic condition, this brominated reagent undergoes an elimination of HBr, leading to this hexafluorobutene. At the same time, the substrate is deprotonated, leading to these enolates, which can react with the hexafluorobutene through an SN2' mechanism, forming this pentafluorinated compound. When using alkali bases, the reaction stops there because the fluoride released in the media is presumably catched by the metal counterion. In contrast, when using a large excess of TBAF, it allows the hydrofluorination of these pentafluorinated compounds, leading to the formation of the desired hexafluoroisobutyl group. This is thus an elimination allylic shift hydrofluorination tandem process, allowing to overcome the usual SN2' mechanism, which is undesired here. To conclude, we developed a new and straightforward methodology to build hexafluoroisobutyl groups. We applied this strategy for numerous functional substrates, and especially for the synthesis of hexafluorosin, which is an amino acid of interest for medicinal applications. So thank you. This is all for me.